Now, RCOCl and anhydrides, I'm sure you have discussed that. The reaction with RCOCl is going to be going faster. Yes?
Yes.
And anhydrides is slightly slower. Both of them are going to be similar mechanisms to esterification. They are both going to be nucleophilic addition elimination mechanisms.
Yes, elimination, my bad, yeah.
Nucleophilic addition followed by nucleophilic elimination.
Sir, you were saying something about the rate of reaction. What is it?
The rate of the reaction or the speed of the reaction is going to be faster for the acid halide compared to the acid anhydride. Acid halide will be faster than the acid anhydride.
I'll read that one.
Okay.
Like for the keeping the constant, the R group and R dash group constant. Or like how do you comparing it? Okay.
Keep it as constant.
Okay. So is it because Cl would be a better leaving group? That is the
Yes.
Okay.
So the next thing which I wanted to touch upon was what is called as tosylation. So tosylation is going to be involving this fellow here, which is called as para-toluene sulfonic acid.
Sir, can I drink water and come back? Just a minute.
Yeah, please.
Yeah.
Now, when it comes to this tosylation here, tosylation is something which I wanted to just touch upon a little bit over here. It involves a fairly interesting compound called para-toluene sulfonic acid. This one which I have over here. Now, what is going to be the advantage, or what is the purpose of this particular tosylation here? What is the use of it? It's like this. So if I'm going to be having the ROH over here, present as it is. All right. Now, usually when you're going to be having the OH group over here, the OH group is not a good leaving group, right? Not a good leaving group. Why?
OH minus is not really.
OH minus is very unstable.
Yeah.
It is absolutely not a good leaving group. So when you want to basically kick the oxygen out, how do you have to basically do it? You convert the ROH into an ROH2 plus. Right, usually. And then you kick this out as a water molecule. Which is not a good leaving group, but decent leaving group. It is not a good leaving group, but it is an acceptably decent leaving group. But you can make this into an even better leaving group by doing this. So if I take the ROH and I react it with the para-toluene sulfonic acid, so when I react it with para-toluene sulfonic acid, what happens is we end up having this guy gets formed. Okay, so this compound here is going to be something where this entire part is called as an OTS group, which is generally an abbreviation for tosyl.
Yeah.
Okay. when it comes to this tosyl over here, what is going to be the speciality of this? What is going to be the advantage of this? So if I have ROTS present now, in this here, this OTS minus, this TSO minus will basically be something where you will have this as the species now. O minus here. This O minus will have resonance.
Resonance, exactly. Two different resonance, yeah.
Right? So this is going to be much more stable.
Yeah.
So this becomes a good leaving group.
So then what's the use of the phenyl, the benzene?
Yes.
What's the use of the benzene there? It's like,
it's just there.
What? Okay. Okay.
As in? I do not understand your question. You're asking why do we need to have a benzene ring? Huh?
Yeah, I mean, like, if the resonance is only between the, why can't we just have
there will be resonance, of course, outside also. That is not going to be helpful here. Right? It is not helpful, but there are two oxygens anyway, two double bonds are there, so no problem. This got enough resonance to stabilize it. So the idea here is this is going to be reasonably stable. You have something to say still.
No, even if the benzene wasn't there, suppose it is CH3S double
That also work.
Okay.
So this is going to be a good leaving group. So what is the advantage of making it into a good leaving group? The advantage is very simply this. ROTS can now do SN2 reactions. You understand what I mean by SN2 reactions? Whatever you studied in alkyl halides, bulk of them will now become applicable for this guy.
Okay, but okay, yeah, got it.
You understand the idea here?
Yes.
So you're going to be having ROTS is now very much capable of doing SN2 reactions, and sometimes when you want to basically remove what to say, or to break the RO bond, tosylation is a good trick. Because when you tosylate, it becomes easier to kick it out using SN2. So to break the RO bond, the steps will be tosylate first, then do SN2.
Okay.
You understand the idea here?
Yes, sir. Okay, that's nice.
Okay.
Yes, sir. Yeah.
Now this is tosylation, so this part is done now. Okay. Now among this bunch here of oxidizing agents, K2Cr2O7 is of course important. Copper at 573 Kelvin is important. Remaining, all of them put together, you can say that what to say, you need like to like just know about all of this. No need to know beyond that. Just know a little bit about the fact that all of these will do oxidation of alcohol to aldehyde or ketone properly. Correspond.
Yeah.
And you're going to be having this.
Sir, what?
You said something just now?
Nothing.
Okay. And in this here, the MnO2 and the Ag2CO3 here. What is special about the MnO2 here?
It is selectively oxidized.
What's selectively? Which one does it attack?
Benzylic allylic.
Correct. So the Ag2CO3 is also going to be doing the same thing. All right. Both of these two guys are going to be selectively targeting only your benzylic and allylic locations specifically.
Hmm.
All right.
Others
So,
also do it, but not selectively.
yes,
Others also attack benzylic and
others
allylic.
also attack them, but they will not
But
selectively target. These guys are selectively going to be targeting mainly and only attacking them.
okay, so yeah.
Okay. Now, other than that, yeah, remaining things seem okay. Now,
So
yes,
he also gave like a few points based on Jones reagent. If alkenyl or alkynyl group or phenyl group are there in the alcohol, then primary alcohol gets reduced to only aldehyde, or else it will get reduced to carboxylic acid.
reduce the oxidase.
So oxidase, my bad, oxidase, oxidase. Yeah,
Yeah, go on.
that's
No, it's fine. Correct them.
okay. Okay.
The idea here is, yeah, I suppose I'll mention that. I'll just quickly describe that part here. So when it comes to oxidation here, one of the key things which you should remember here is this. In the stages of oxidation, what happens is you're going to be having ROH, alcohol, becomes the aldehyde. Or in some cases, it can also become the ketone, which then ends up becoming the carboxylic acid,
Hmm.
which then usually ends up becoming carbon dioxide.
Okay.
These are the different stages of oxidation. Okay.
Yes.
Now, when it comes to each stage over here, you're going to be having some stages are going to be tougher than the previous, some stages are easier than the previous. So in this case here, alcohol to aldehyde or ketone is a difficult stage.
Okay.
But aldehyde to carboxylic acid is an easy stage. Similarly, ketone to a carboxylic acid is a very difficult stage.
Oh, okay. Hmm.
And the last one, RCOH to carbon dioxide, conditional case or condition specific case. So it happens when certain conditions are satisfied. It does not happen if conditions are not satisfied.
Hmm. Okay.
Okay. So that is basically the idea over here. So this is basically how your oxidation goes for different stages. Problem is going to be this. When you're going to be having alcohol in this pathway here, have a look at the black mark pathway here.
Yeah. Hmm.
You're going to be having a difficult stage followed up by an easy stage.
Yeah.
So what happens in that particular case there is when you're having a difficult step followed up by an easy step, both steps will happen together.
Okay.
You understand the idea there? If the
Makes
oxidizing agent is going to be something which is like reasonably even decent, what will happen is both steps will happen together simultaneously.
Hmm.
So when both happen together, what's going to be happening is you're going to be not capable of stopping the reaction at the aldehyde stage. It will go directly to the carboxylic acid stage, which is basically what you're talking about here, right? That's what you're saying, no?
Yeah, exactly. Yeah.
And if it is going to be giving you the ketone, though, it will stop. No problems. No issues with ketone. The problem is going to be only when it comes to the aldehyde there, because the aldehyde can easily undergo oxidation to become carboxylic acid.
Okay.
You understand the idea so far now?
Yes, sir.
Okay. Any other doubts in oxidation so far?
One second. Just a second.
Any other doubts regarding oxidation?
Just a minute, sir. One second.
Yeah.
So this is not exactly what he wrote, right? Like he told that if there's an alkenyl or alkynyl or phenyl group, then primary alcohol gets oxidized to aldehyde. How are these to say?
Or what?
Sir, if alkenyl or
Is
alkynyl
what?
or sir,
With?
Jones reagent.
No. Jones reagent is basically saying that Jones reagent, you will have aldehyde happening there. He's saying, what is the product given there? You give me the full thing. Now tell me the point now.
Sir, he said if alkenyl or alkynyl or phenyl groups are there in the alcohol, the primary alcohols get oxidized to aldehyde only.
And it stops there is what he's saying.
Yeah, he said only aldehyde. So I'm guessing it stops there. Oh yeah. And then the next point he gave said it said if these are not there, then it continues to form carboxylic acid.
Yeah. So basically he's saying that when you're going to be having alkenyl or alkynyl, you're going to be having some resonance happening over there, which is going to be stopping the oxidation at that stage.
Okay, resonance is the key. Okay. Yeah, no. Okay.
So the resonance is going to be involved with the aldehyde over there, which is going to be capable of, for whatever reason, stopping the oxidation reaction at that stage there.
So basically, second step will also be hard. So don't bind into the same step.
Yes, the second step becomes more tougher there.
Okay.
Basically, instead of having it as a very easy stage, it is becoming a slightly more difficult stage. So if it becomes a slightly more difficult stage,
Both are not
automatically
fused
stops
together.
out there.
Yeah.